Hello, this is Greg Braun with Cognex Corporation, Duluth. We're going to be giving an online session here. This online session is going to be called Flaw Detection. Just a short overview and some lab work and application work, and we'll see what questions we have after that. So if you would please bear with me through these short lecture slides here, and we'll get into the application then briefly after that. On your screens, you should be seeing a slide that says, or a PowerPoint that says flaw detection. And as we progress through, we're going to be learning what the defect detection soft sensor does, how we look at the live image versus the model image, and the residual image, what is it, how a mask affects the residual image, and of course drawing and positioning the soft sensor and some of the explanation of the parameters. As you can see in this first slide, we have flaw detection. We have this emblem on here, which is the good part, the model image, and to the right here of that, we have two other images that are the defective parts. As you can tell by just reviewing the images very briefly, it's very hard to tell what the defects are. As you can see in the next slide right here, the defective parts are on the left, and the actual residual image, in other words, the inverted pixels, denote what the defects are. What they're doing is looking at the pixel intensity, see if there's any change, and if there is a pixel intensity change, they will invert that pixel. So you have a black background with a white inverted pixel where the defects are. There will be some steps we'll be taking. The first step will be, of course, creating a positioning tool to find the object. This is a positional relationship between the flaw detection and a object moving in the field of view. We will have to place that flaw detection tool precisely on that object, so we will require positioning. Second step will be draw the actual flaw detection tool and adjust for the error detection parameters and tweak some of the other parameters for pass-fail. The first step, of course, is drawing the object locate positioning tool. I say the object locate positioning tool because we are going to be using some precision placement of our tool, and we will need more accuracy than what a blob tool would give us. So my choice here would be the object locate positioning tool. Some of the typical parameter adjustments would be use accurate positioning, lower the pixel distance, and if needed, increase your best match selection. You'll notice on the image right here we also have a orientation. We will absolutely need that for rotational information. Next slide, we're going to be looking over the learn the model image to compare with a live image. That's what we're basically doing, making a template to superimpose over that live image. Then we take the live image minus the model image, will give us the difference, meaning the difference in pixel intensities. If there is any, it will invert the pixel and show it in white. And that's what we get with the difference minus the mask, which will give us the residual image. The mask image is computed by finding a gradient value. In other words, the edges around the product that we're examining, inspecting, and then we learn from the learned model images. Step two then would be to actually draw the tool around the object. Now this we can do several ways. We can draw the border of this box within the product or somewhat outside of the outline of the product. When we draw it outside of the product, that part between the product and the border of the tool will be included in the inspection. Sometimes it is best to draw it right along the edge of the product. It automatically learns the model object. In other words, it will learn the pixel intensities within the learn box parameters. Then after that, we should chain this flaw detection tool to the positioning tool to place it as the product moves within the field of view. When we're within the flaw detection tool, there are several options here. In case we did not quite learn it the way we wanted it to teach a template, the model object, we can relearn the object if any mistakes were made, as can be indicated in this training tab right here, the relearn button. If in case you have some variances of your product, perhaps some edges that have a little bit more flashing on them or whatever, and you think that is acceptable, you can actually learn more than one image, and you can learn several images here. That is a task done under the Training tab. Next we have the mask. What exactly is the mask? The mask is found from gradient edges of the golden image. In other words, they are masked out. They are ignored pixels intensities around the edges. Why we want to mask out edges are, that's where you get the most reflection or the variances in the lighting from the actual edges. So we actually ignore those pixels along your edges using the gradient threshold technique of finding edges where the rate of greatest change between a background and a foreground, or between an object and the other surrounding. As you see here, we have add to mask. We can expand the mask. That will disregard pixels at all the edges, as you can see here by this second object here. The actual mask lines are these inverted pixels here. So at the edge here, we will be ignoring the pixel change intensities right here. And on this second image here, you'll see it is much wider. Now, if we have a unique imperfection somewhere else on the product, then we can add to mask. And that will include all the pixels to be ignored that have different intensities than the actual model that were not part of the original mask. That is for anomalies that are not part of the edges. And if there was an area that was not quite specific and more random, we can use a program, a utility program called Paint, to actually white out that area and have those pixels ignored. And we'll talk more on that later. Part of the Training tab, under the Training tab, we'll have the box down there for live images so that we can actually look at the model, look at the live image it's looking at, and then we can specify how we want it to present. In this instance, I'm looking at the residual image. So we're taking the model image and we're comparing it to the live plus your mask. Now this one happens to be an expanded mask, so the results may be viewed in the residual image. In our second live image here, I have actually some flashing on the right-hand hole here, and on the left I have some flashing and some little bites out of the edge here. But in our residual image, they do not show up, only the large area here with the flashing. That is because we've expanded our mask, and this small amount of defects here was actually ignored. As far as settings go, another tab on our flaw detection dialog box. On this one, we indicated our defect size would be at least 100 pixels. What I mean by 100 pixels is the minimum number of pixels that are touching, or each side of the pixels, or as we indicated right here, each side and each corner of the pixel must be touching. And that's what considers this area defect right here. If you are familiar with the blob tools, these are basically following blob principles. And especially when you look down here at the post-processing residual images, we can dilate, erode, or open and close on these defects to change their size properties. Once we have those figures, the model image and the mask image, we can save these to be imported into other cameras or save them on the PC, and also to be allowing for some masking editing of the mask over here. We can save this mask image and load it into a program, a Paint program, utility program we call Paint, and white out certain areas to ignore, and then reload it back into the product file. In our pass-fail criteria, we're going to have max defects and total defect area. And this one, it happens to be max defect count of 1. It will default to 0, so if you have any defects, they will show up. Realizing, of course, in the parameter back here with our defect size, we have to have at least 100 pixels for it to show up as a defect and thus be counted. So what are some of the pitfalls when drawing this tool? Well, we won't chain it to the positioning tool. The product moves, and of course we're looking for changes in pixels intensities. If I'm looking at the conveyor rather than the product, it will probably be a different pixel intensity and show up as a defect. Some of the parameters are either too tight or too loose, and we'll go through some of those parameters as I show you through some of the applications here. Then in conclusion to the lecture part or slides, we have here, if you remember, we require the model to be learned. We'll have to teach it that model. We'll want to be able to use some part tracking to accurately position that model image onto the live image, which is our product. We can also rotate this tool through our positioning tool, and the learned models are stored in the product file, so they are actually part of your product file. They are not saved out on your PC like many of the other images you would do. Defects are difficult to detect on textured backgrounds. The reason I put this in here in conclusion is because if you do have a textured background, you will try and draw your sensor as close to the product as you possibly can, so to make sure you have the textured backgrounds. Or if you're trying to find defects on a textured product, it will be very difficult because the textured background will change positions. As they change positions, the pixel intensities will change. If those change, then you will show them as defects. If there are no questions, which I doubt if there are, at this point, we certainly can go over and work on the actual application itself. What I'm going to do here is share my application so that you all can see what I'm doing here with the application. Right. So here you should all be viewing the application. I have a small bracket with 2 holes on it, like they were in the slides. To just demonstrate how to draw the tool, I am going to be drawing just the defect detection tool. This object is not moving. As you can tell, I've just put some flashing in one of the holes. It's not moving, so I'm not going to put a position tool on this, just for demonstration purposes only of demonstrating the defect detection tool. So I will draw the flaw detection tool slightly outside the edge of the actual tool itself so that you can see the entire image here. I'm moving a little bit here. So here we have the flaw detection tool. Naming it that. And what I would like to show you is some of the different tabs. I'm not going to work too much on the shape in those areas. Those are other tools that we can go over with later if you have those questions. But here I have my training tab right here, the learning box. Here I have the relearn in case I made a mistake and happen to not want to learn this one. I could hit that again and it would relearn it. A mask expanding factor, I'll go on over with this box down here. The learning images, one. Of course, I just want to learn the first one primarily, but I can learn several if there are product variances. In the second example, I will show you how to use that. Let's go down here and see exactly what it is doing. I drew the tool so it automatically learned the model. As I advance at one image, I notice I have flashing in this right hole, and down here in our tools, we have here defects 1, total area 1,395 pixels, and it has failed. So everything is working correctly, but let's take a look at what some of these image markings are doing for us. We'll go back to the original image here. I'm on the live image. If I go to the mask image, you'll see these inverted pixels along the edges here. These are masked out, so I do not regard those pixel intensity changes. As I go to the residual image, you'll see the total model here is dark. That's because there are no changes in the pixel and intensities. But as I advance at one to where we had the hole with flashing in it, we'll notice here that we do have a inverted pixels right where the flashing is. So that's our residual image, but if I went back to my model image, we'll notice, hey, there is no, because that's our model image with no flashing in it. But we still have a teal-colored dotted box around what the actual flaw is, and when we look down here in our table, we still have it there, so it is representative. That's because we're looking at a model image. Here is the actual live image. Now let's go back to this expanding mask. If I will, please, let's put the mask image up here and see how it affects this. I've got an error, total area of 1395, 1,395 pixels. As I expand the mask, I went from 1395 to 1383. So you can see I am ignoring more and more pixels, 1379, as I increase my masking area. This is not necessarily done because I'm also masking out all of the edges. Maybe I just want to mask out this particular area, and that's where that utility program paint would come in handy just to white out this small area over here. I'm going to go ahead and shrink this back. I don't want to shrink it too far back. If I do, I will have to hit a relearn image, because what I've done when I've gone too far is I've given it no area to be able to mask out. I've got an area here of total area of 1513. So obviously I would have to relearn this. If I hit now, it would be an accident because I actually now, as you see this highlight around the flashing, I have 0 area defect. So I made a mistake of relearning the wrong image. All I need to do is go back to the golden part eventually, which you will see has 0 total. Oh, it does. Here we go. I'm in the actual live image now, which has 0 defects as you and I would see it, but our result table down here shows us we have defects because where it is flashing was supposed to be part of the model is not. So I will just go ahead and relearn this one. And then we will show up with a proper sequence of failing on the second image. Enough said on that. If there are any questions, I'm open to them. All right. We'll go ahead then and carry on with the next demonstration. I'm browsing for some images here. I'm going to be looking at the no smoking, and these are all available to you off the website, these images, for you to practice with if you so desire. So I'll go to a new product here. What I have here is a round image of product, not a square like a bracket, so I will be using a different type tool. Again, I'm not going to use positioning right now to show you the differences of the effects of what happens. I'm also going to be picking an ellipse instead of a square to go around this object, because I do not want to do as little of the background as possible. And so here I have my no smoking defect detection tool generated. As I advance it one, you can see I have here a scratch on the smoke part of it, and I have no defects down here. Well, we're going to move to the settings instead of the training tab. On the settings tab here, I have my defect properties. My defect size right here is 100, so maybe I will go to 50, and I will take and apply there, and I still have 0 errors. Go to 25. Yes, I do find an error. Then this small scratch here is merely 30 pixels in area, and that's why it did not show up and did not fail for it. As I advance, the image is not moving. I still have another error here, 33, but it's not here. I can look for this turquoise box right here and see, yes, it is the end of the smoke right there, and there's again a small area there to discern. And as I advance it one more time, I don't see where the turquoise line is, but I notice I have a defect, so it is very hard to find. So this is where it comes in handy. Go back to the training tab, look at our image marking, and change it to residual image, hit apply, and we see a small band right here in the lower left-hand corner. So when I go back to my live image, we can see, yes, there's that teal-colored area, and it is part of the band has changed. As I advance again, I get a tremendous amount of errors because obviously the object has moved, so I need to get to positioning. Before I get there, though, I want to do one more thing and show you I'm on image 1. What I would like to do is say these errors are not major enough to stop this product from running. We want to go ahead and produce this as is. I don't want to mask out those areas because if I expand all the masks, it'll just expand all the areas. So what I want to do is add these small variations. They're in the same place all the time. So what I will do is I will learn several images. I'll learn the next 2 images, or 3 images, let's call it. I will go ahead and hit relearn. And down in my result table it says remaining learning images are 2. So as I advance this one, it goes remaining learning images 1. So I've added the scratch. I've added the smoke, or the tip of the smoke here. And it has no more remaining images. And so when I go to the next one, yes, this band right here did show up as an error. But as we go backwards, tip of the smoke did not show up. The scratch did not show up. So I added those to the actual model image. Remember though, we still had one more issue to take care of, and that was positioning. I will have to go back to my image 1, my golden part where I learned from. I'm going to go ahead and say OK to this tool. I've got the parameters set up pretty much the way I want them to be. And I'm going to go to a positioning tool. I'm going to use an area positioning. I don't need the whole object. I could do the whole product. But I'm just going to pick a small portion right here, since this will give me lots of angle information. Change my options. Remember I told you blob tool would not be accurate enough, so I want to change it to object locate. And I will leave it there just to show you some differences here. So I'm going to say OK to that. Open up the no smoking flaw detection tool. Make sure I reference it with it. It doesn't necessarily work well if you don't do it that way. And I'm going to go ahead and go advance this again, so that has no errors, that has no errors. It still picks up this small no smoking error. But now as we change position, we're just picking up, instead of those thousands of errors, pixel errors, we now just have a total of 4. We have here some imperfections on the end here and another one. Again, if I could not see these as easily, I'll go here to my residual image. And I'm able to pick up, there's the band again, and then there are 3 blemishes on the actual no smoking. So as we keep advancing, we'll see what happens here. As it rotates around, we just have a small area right here at the end of smoke. Yep, that is understandably. And we have another area that is up here in the top, just a slight cut on the outer ring of the no smoking. Possibly something that we wanted to include in it and saying it's an alright error, just like we had before. So we can go back and make this relearn 3 or 4 images and add this to that. Expand the whole mask, but then all these other areas down here. So I know my band right here would change, and I want to be able to detect if that is an error or not. So a possibility would be to white out that area. And let's see if there's any other errors. There's a couple right here, okay, that I do believe are not errors, but possibly due to maybe my pixel, my object locate tool is not accurately positioning this. So what we can do is go ahead and just say OK to this for a moment. Go back to the positioning tool, open up my parameters box and say I want to use accurate positioning. And that did it right there. As you can see, these 2 other areas I needed accurate positioning. Almost most of the times when I've used this tool, I've had to indicate accurate positioning. When I say pixel distance, this one is one I mean right here. So our template that we use with our object locate is much closer to the actual product here. Lower that number down also. And go for the best match. Normally, accurate positioning will get it most of the time. Possibly go with pixel positioning or pixel distance, lowering that number to 2 or 1, and then go to first match. So again, that helps us get rid of those small minor errors right here that weren't really defects, they were just positioning issues. And as we advance, we're going again. We have some more positioning issues. So let's go ahead and open that up again and lower this down. And as you can tell, now we've gotten rid of these small minor issues here with positioning and gotten back to the true errors, which are the smoke gear missing the band in the wrong position. So we have 2 errors right here. I reduced the pixel distance down to 1. I did not have to go to best match. And we are back to the first image. As you'll remember, I noted up here we had some issues with the very top part of this ring. I did not want to expand the mask. So what we can do is actually go in there and just train a small, or white out a small portion of it. So I'll open the tool once again. I'll get down here to images. Mask image is what I'm looking at. So I want to save this mask image. We'll call it top ring. And we'll go ahead and see how to do that. I'm going to try and load it, but before I load it, I want to change it. So I'm going to right-click on top ring. Go down here, open with a paint program. And here we have kind of a dark image here. So what I want to do is kind of white out. So I want to pick white here in my paint program and white out the top part of this where I had that error before. Just white out this part. I'm not doing a very good job of drawing, but now remember, this will ignore any pixel differences in here, so you could have other defects, but what we're trying to do is just address the outside of this. All right. We'll go ahead and save this. All right, I will save that one. Then I will go back to, go ahead and cancel this and load it. I've already saved it. I don't need to save it again. So I'll open this one in here. And let's see if we have that. One of the techniques, again, go back to training. Take a look at my residual image, or my mask image. And yes, my mask now has that whited out area up here. So I was able to load that successfully. And as we, well, I don't want to really look at that. As we go through our images again, that's no error, no defect there. Yes, it shows up as a defect. Positioning is not an issue here to show up false defects. That is correct for a defect there. As we advance along here, we do have a small area up here that I did not quite white out. I would have to go back in there and load that mask into the paint program, white out this area up here, and it would be able to pass with that. How it's used in a practical application is there was an industry that was looking for defects along a car door. Problem is the sensor was looking at the car door from inside out, and it was looking at people walking behind there occasionally, and of course the people would show up as, not defective, but as defects in the result table. So what they did was white out the inside of the windows so that they were ignoring any changes of pixels on the inside of the door frame, of the window frame, and just inspecting the bead across the top of the actual window frame. So again, this is how you use a whiteout application, just to ignore those pixel differences. And that looks like that concludes any of the actual tool demonstration with this application. I'm going to go ahead and turn back. To our live meeting here. And today I would like to thank you. Just a short, brief session on the defect detection tool that is present in the Intellect 1.0 to 1.3, and the new flexible flaw detection tool will be present in the 1.4 Intellect software. But also you will have the availability of the defect detection tool in 1.4 and above also. I want to thank you for joining us today, and we will be seeing you next week at another online session. Thank you.
The moderator has disconnected. At this time, the conference will be terminated. Thank you and goodbye.